Welcome back. Now that you understand why quality of service, QoS, is important, I'll detail some key components that make it work. In this second of a two-part episode of Cisco Tech Talk, I'll finish explaining QoS and demonstrate how to set it up on a Catalyst 1300 switch. Next. To achieve quality of service, QoS, networks use several mechanisms to manage and prioritize traffic. The process begins with classification, where packets are identified and labeled using tools like access control lists, ACLs, differentiated services code point, DSCP, and class of service, CoS. An ACL is an ordered set of rules that helps filter data, controlling what data comes in or goes out of a network interface. CoS is a value in the VLAN tag at layer 2 that helps prioritize data frames. Frames from specific VLANs are prioritized using the 802.1q tag. A CoS value stays with the frame as long as the VLAN tag is there. Once the tag is removed, the CoS value is gone. DSCP works at layer 3 and is included in the IP header. It stays with the packet from start to finish, helping prioritize it throughout its journey. Unfortunately, DSCP values can be changed by network devices along the way. So even if you set them, they might be altered by devices you don't control. QoS marking helps prioritize important data to ensure it gets through quickly and reliably. This marking creates different classifications of service for different types of data. Marking can be done at layer 2, layer 3, or both. At layer 2, you mark the CoS value. At layer 3, you set the type of service field in the IP packet header. Shaping controls the maximum rate of data to prevent congestion. It limits the data sent from an interface. Policing sets an upper limit for data. It helps manage network traffic based on predefined rules. If there's too much data, it can be remarked or dropped. Queuing helps prevent congestion by sending data to specific queues for processing. Data is then sent out based on bandwidth allocation. Bandwidth allocation determines how much capacity is available for data, subject to QoS rules. Trust mechanisms in network devices help keep data quality consistent. When a device trusts incoming data, it passes through with its priority settings intact in the absence of any explicit policy configuration. Upstream references data coming into the device, ingress. Downstream references data leaving the device, egress. This ensures that important data gets treated the same way across the network. On Cisco 1200 or 1300 series switches, QoS can be set up in basic or advanced mode. On the QoS properties page, you can configure QoS. In basic mode, there's an option to define a trusted domain where packets are marked with 802.1p priority and/or DSCP to signal their service type. Nodes in the domain use these fields to assign packets to specific output queues. Initial packet classification and marking are done at the ingress of the trusted domain. To set the trust mode for basic QoS settings, go to the Global Settings page. Define trust mode as either CoS, DSCP, or both. Once selected, traffic will be mapped accordingly. If you choose both, either CoS or DSCP will be used. You may enable Override Ingress DSCP to change the original DSCP values in incoming packets with new ones. When enabled, the device uses the new DSCP settings for outgoing data and replaces the original ones in the packets. To modify the DSCP output, click Apply to save the changes. On the Interface Settings page, there's an option to enable or disable QoS on each port. To do this, select a port. Click Edit and make your selection. If disabled, all incoming data on the port goes to the best effort queue with no classification or prioritization. If enabled, the port prioritizes data based on the system-wide trusted mode, either CoS or DSCP. Click the Save icon to apply the settings. There you have it. Setting up a network for your small business doesn't have to be daunting. QoS helps your network run efficiently, providing a better experience for both your customers and your staff. Thanks for watching. I'll see you next time.